Hi, folks. Welcome to part 3 of 1.2. And this last section here we're going to talk about is something called piecewise functions. And so we're actually going to start off with, I think, is a pretty juicy example, but an example that I think was so important to my understanding of how money works and how taxes work. And so I thought I would share that with you. So what we have here is this 2023 tax table, assuming that you are a single filer, meaning that you're not married or you don't have a domestic partner. Okay, you're filing your taxes all by yourself. And this chart here gives us an overview of how much you would pay depending on how much you would make. All right. Now, it is important to note here that this is for federal taxes only. And so if we were to look at state taxes, that might be a little bit different, and it would be in addition to the federal taxes, okay? But for the federal taxes, if you look at this chart, this is how I thought I was supposed to read it, okay? I thought that if you made somewhere between $0 and $11,000, you were taxed at 10%, right? And then I thought if you made, as soon as you made $11,001, that meant that everything was taxed at 12%. But it turns out that it's actually the 10% of everything up to $11,000 plus anything over that. So if I made $11,001, I would only pay 12% on the $1. Everything else I would pay only 10%. Okay. So let me actually show you an example of what I mean by that. All right. So let's put an example here. Let's say that you make $11,001. Okay. So what I thought was that you would take your income and you would multiply all of it by 0.12 to find 12%. And that ultimately I would owe the federal government. Let's get the numbers right. I would owe the federal government $1,320.12. Okay. Now it turns out that this is the wrong way of thinking. Okay. Let's go back up and read what the chart says a little bit more carefully. The chart here says if I make $11,001, I pay $1,100 plus 12% of the remaining. So really, what I'm doing is I'm taking 1,100 or 11,000 times 0.1 plus the difference. So whatever that is, in this case, it's just the extra dollar times 0.2. And when I plug that into the calculator, I end up with $1,112. And this amount is correct, right? So my mistake was I thought I had to pay 12% on everything, meaning it was almost $200 more. But it turns out it's 10% for the first bucket and then 12% for the second bucket, okay? So let's try another example, all right? So let's say this time, instead of making just $11,001, I actually make $44,725, okay? So let's see what that would be like. So 44,725. Okay. So I thought that I would take all of this and pay 12% of that, which would be 44,725 times 0.12. That would be $5,367. Okay, that's what I thought. But it turns out I got to do something kind of like this, right? the first bucket is only 10%, and then the second bucket is going to be 12%. Now, since I chose a new number, instead of this 11001, I'm going to put in the 44725, okay? Because now I'm making a little bit more. So 1100 times 0.1 plus 44725 minus 1100 times 0.12. Let's get that into the calculator. Let's see what that gets us. 44725. And this gets me 5147. All right. So again, instead of paying what I thought was 12% on everything, turns out I only pay 12% on the chunk that's into the next bucket. So anything over the 1100. Okay. So let me add a page in here. But let's go back up to this table for a moment, right? And the title of this section is something called piecewise functions, right? And so, yes, taxes are important, but also in the big picture, sometimes we run into situations that we really need more than one rule in order to figure out what's happening. Okay, and taxes is exactly a situation where you need more than one rule to figure out what's happening. Okay, this is where we come in with the idea of a piecewise function. Okay, so we're not going to do all of this. In fact, I'm going to leave you some of this as optional extra credit if you like. Okay, but we're going to go ahead and do the first 3 pieces of this piecewise function. Okay, I will leave the last 4 for you to do, all right, if you like. But we're going to do the first 3 together. So let's say that we wanted to write a function for taxes, right? So maybe we say the taxes t of x. And normally we just have an equals and then we write one thing here and we're done, okay? But for the piecewise function, we actually have a really big squiggly bracket. And then since we're going to do 3, we'd have 1, 2, 3 different pieces. Okay. And so a piecewise function, we can think about it as like 3 different equations that all happen at different times. And so we can put them all together to show a picture of what's happening. Okay. So in this particular model, all right, let's go back up here. We've got a 10% tax rate as long as X, or your income, is between 0 and $11,000. So here's how I would write that in a piecewise function. Okay, I would write 0.1x. The 0.1 is your 10%. And that is from 0 to x is between 0 and 11,000. Okay. So this first line that we've written here is the same way as representing this first line here. Now, remember, we can't just then say 0.12x for the next clump, all the way up to 44725, right? It's not 12% of everything, but we can write it something like this and this, right? So the things that changed are the number that I plugged in here. All right, so that is my salary. That's my X. But everything else, this part and the 12%, that all stays the same. So if I were to write one to model what happens at that next tax bracket, I would say 0.1 times 11,000 plus 0.12, that's your 12%. Did I leave myself enough room? Maybe not. Scooch that over. 12% of x minus 11,000. Okay. This takes care of the sum of it. The first bit, we only pay 10%. And this says for the second bucket, we pay 12%. Okay. Now I know I said I would write one more of these. So let's go back up and find the third line. All right. So now we've got 22%. As soon as we're between 44726 and 95375. Okay, so goes up substantially. So let's see if I can remember these numbers. All right, so we go from 44725, everything bigger than that, all the way up to 95375. Okay. So in this, what we would call the third tax bracket, we still get to pay 10% of the first bit. So 0.1 times 1100. Okay. And then we pay 12% of the next clump. But that's not 44725, but it's the difference between 44725 and 1100. Okay, because 11,000 of it, 11,000 of it already we paid 10%. So everything between 11,000 and 44725 is going to be 12% plus 22% of anything bigger than 44725. All right. So a little straightforward if we're only making a little bit at the bottom. A little bit more complicated as we move up. And for each tax bracket that you move up, you still pay a lower percentage for the bottom amounts and a higher percentage for the top amounts. Okay. So if you are interested, I'll leave you with this extra credit. If you complete the last 4 brackets, okay, last four brackets, and explain your reasoning to me. So in other words, explain to me how you got your formulas. Okay. So you're gonna find your 4 brackets, all right, the last 4 brackets, find the formulas, make sure that you know where it comes from, be ready to explain your reasoning, and you're gonna make an appointment with me, with Judy, over Zoom, and explain it to me. All right. So here's a little sort of entry into piecewise functions, but one that I think, I wish we could say we don't have to pay taxes, but at the end of the day, we do. And it's probably better that we understand the system that we're up against. Okay. So a little light but also important extra credit in case you want it. But if you don't, it is completely optional. So don't worry about it if you don't want to. All right. Let's move on to example 11, which is going to be a lot more like the level of stuff that we'll see in our class. Okay, so let's think about another scenario. So let's say a museum. You can go to a museum. They charge $5 if you want to go on a guided tour. But if you have a group of more than 10 people, 10 or more people, then you only have to pay $50. Doesn't matter how many people you have, it's just a flat fee. Okay. And so our task is to write a function relating the number of people n to the cost c. All right. Now, it seems like there are two pieces here. All right. So I'm going to set up my C of n and a squiggly bracket. All right. And one of my cases is going to be from when I have 1 to 9 people, right? For every person between 1 and 9, I have to pay $5 per person, okay? And if I have 10 or more, so how do we write 10 or more with notation? We say n is greater than or equal to 10, okay? So if you have 10 or more, it only costs you $50. It doesn't matter if you have 20 people, 30 people, 100 people, it still only costs $50, okay? So for n greater than or equal to 10, we can actually say that the function is just $50, the cost, that's it. But how do we write it if we want $5 per person, right? So one person would be $5, 2 people would be $10, 3 people would be $15. Okay, so maybe what I'm doing is I'm taking 5 times the number of people, right? That would tell me how much I have. So even though this was 2 different scenarios, right? One for a smaller group of people, one for a larger group of people, I can write it together in what we call a piecewise function. All right. Now, let's talk about how we read a piecewise function. So here it says evaluate C of 3. So now that we have more than one function, how do we know which one we use, the first one or the second one, right? That's a super valid question. It turns out that this number in here will tell us which one to use. So 3 is between 1 and 9. So I'm going to use this function, 5n, right? So C of 3 is 5 times 3, which is the cost of $15 if you have 3 people on the tour. So part C looks similar. Evaluate C of 12. Okay, well, C of 12, 12 is bigger than 10, and the cost for 12 people is going to be $50. So we can say C of 12 equals $50. Okay, so even though we write a function that has a lot of pieces, the piece we choose depends on the number that we put in. Okay, all right, last but not least, we are going to evaluate C of n equals 40. Okay, so in other words, 40 is equal to one of these 2 functions. Now, I think we can reason they didn't have more than 10 people. They didn't have 10 people even, because that would have cost $50. So C of n equals 40 will actually equal 5n. We use the first piecewise function. And now to solve for n, we divide both sides by n, or 5. So 8 equals n. That means that there were 8 people that went on the tour. Right, so let's get that all here on one page. But a museum charges $5 per person, and we can sort of think about this in 2 different scenarios. And when we're trying to evaluate, we have to choose the right scenario. Not both of them, we have to choose the right one. All right, let's finish up this lesson with a graph. Love the graph. All right, so a little bit more dry. There's not really a real world scenario here, but really thinking through the mechanics of like, how do we graph? What do certain shapes look like? Things like that, okay? All right, so this is a piecewise function that has 1, 2, 3 pieces, and each piece is defined by a different equation. okay? So since this is the first piecewise function one, I thought I would give us a table down here to practice plugging in values and think about what numbers we should plug in, okay? So I'm going to go ahead and plug in 0, 1, 2, 3, and 4. And let's see how that goes, okay? So if I plug in 0, which one of the 3 equations should I use? Well, 0 is not bigger than 2, so not the last one. 0 is not between 1 and 2, so not the middle one. But 0 is less than or equal to 1. So it turns out for this first one, I'm going to use x squared. So 0 is x, 0 squared is 0. That means one of the points on my graph is 0, 0. All right. Next x up is a 1. Should I put that into the first equation or the second equation? Give you a moment to think about that, but our clues are really in the symbols, okay? Turns out we're going to use the first one again because x is less than or equal to 1. 1 is equal to 1, and 1 squared is 1. So 1, 1 is also a point. All right, next number up is 2. 2 is going to get plugged in here, and it's just going to be 3. So at 2, I'm up at 3. All right. And, oops, let me write that in. At 3, well, 3 is bigger than 4, so it's just going to be 3. And same thing with 4. So 2, 2, 3, 3, and 4, 4. All right, so it kind of looks like a bunch of weird dots. So let's talk about some things that might help us visualize this a little bit better. I know that x is a line. And so from 2 and bigger, I have this line, okay? But that, my friends, is only from 3 to 4. But technically, if I had picked like 2.1, I would still get 2.1 out, all right? So it turns out that it gets all the way to here, but because this is a greater than, we have an open circle here, all right? Now, this middle piece is just 3. That means everything has a y value of 3 between 1 and 2. So from 1 to 2, I have a second piece. All right, and working our way backwards, x squared, I hope we know, is a parabola, but we only want the piece of the parabola where x is less than or equal to 1. So that would be like this part right here. Oops. All right. And so we basically have 3 different graphs, but we slice them up according to what we have here, our intervals here, and then we glue them all back together into a picture, okay? The table can be helpful if you like plugging in values. Always feel free to make yourself a table. But as we move forward in this class, I want us to get really solid on graphing different shapes, okay? All right, so last thing, let's determine or evaluate a few things. All right, so let's start here with determine f of -3. So -3, which piece does that fall under? Well, -3 is less than or equal to 1, so I'm going to put it into the x squared. All right, so f of -3 equals -3 squared, and -3 squared gives us a +9. Okay. All right, next up, evaluate f of 1. Evaluate f of 1, evaluate is the same as determine, right? I just wanted to mix up the wording and make sure we understood that. Evaluate f of 1, now we got to choose the right piece to put it in. Well, where is x equal to 1? Still that first one, okay? So f of 1 equals 1 squared, which is 1. So we've got +9 and 1 so far. All right, last two. Find f of 1.1. Well, 1.1, that's not less than 1. It's not equal to 1. But it sure is between 1 and 2. And if x is between 1 and 2, the y value is 3. So f of 1.1 is 3. Okay. And last but not least, determine f of 3. Okay, let's see which of the 3 function pieces we should put it into. Well, x is 3. That's bigger than 2. We're going to put it right into there. And so whatever our x value is, that is also our y value. So f of 3 equals 3. All right. So folks, there you have it. You should have a little bit more practice on this kind of stuff in the MyOpen Math, but also in the quiz for week 1. All right. Let me know if you have any questions.